because we had a lot of people absent and not here on Friday to finish up the notes, I decided to make a video over all of the notes. First thing I want to remind everybody is that you'll be able to use this page from the notes on your test. It's actually included on the test, so what I would do is just be careful with kind of the wording and what everything means. So first we're going to talk about graphing rational expressions, and in this case this will be the numerator. And then the b of x we'll be talking about is the denominator. Basically what you're looking at when you kind of look at these are the f of x sometimes can be thought of y equals. So when you look at that, make sure that you guys are thinking of y equals also. It could be g of x, it could be h of x, it could be, p of x. There's a lot of different options for that, but most of the time if you see an f of x, it's really just a y equals also. They are polynomial functions, so more than one term usually on top and bottom. Next. Alright, so there's going to be things that you have to look for, and the way this works is I would always start at the top of this list and work my way down. So in the case of wholes, what you're actually looking for are common factors and what makes the common factor equal to 0. So in an example, if f of x is equal to 3x parentheses x plus 2 over x plus 2. And on some of these questions, you're going to have to factor, you're going to have to cancel out, you're going to have to kind of do all of the steps that we've done so far for solving, but you need to get it to here so you can actually see which ones cancel out. Instead of marking it out, I'm going to circle it on here. So this is a common factor. So that is a common factor. When you look at that common factor, what you're actually looking for is what makes the common factor equal to 0. So it is the same as a kind of an excluded value, but it's what makes the one that cancels out equal to 0. So in this case, the number that makes x plus 2 equal to 0 is x equals negative 2. Now here's the issue. After you cancel it out, your problem is actually f of x is equal to 3x over 1. And you don't need the 1, but I'm going to show it anyway. Wholes are not thought of as x equals numbers. They're actually thought of as ordered pairs. So negative 2 is the x value. The question is, what makes this y value? And what you have to do is you actually have to take the negative 2 and plug it back into f of x after you simplify. So you have to plug it in over here. So f of x, or y, equals 3 times negative 2 over 1. So y, or f of x, is equal to negative 6. So inside of here, the whole is actually at negative 2 comma negative 6. So you're actually looking at the whole as an ordered pair on the graph. So you have to simplify it, you have to look at the problem, then you have to take your x that makes it equal to 0 and plug it back in. If you try to plug it back into the original problem, you can't, because remember, the negative 2 makes the denominator equal to 0. So it makes the denominator equal to 0. Alright. Next on your list. So the next thing you would find on your list is a vertical asymptote. And the way vertical asymptotes work, an asymptote in this case a vertical asymptote, is an imaginary vertical line, which is always x equals a number. Your graph cannot cross. Alright, so it's an imaginary vertical line that your graph can't cross. And basically, after you simplify and after you figure out your holes, whatever's left in the denominator, your vertical asymptote is that. So, let me make up another example here. So, example is y equals 2x parentheses x plus 4 all over x parentheses x minus 3. So I would tell you to go through the steps. So if you were going through the steps, the first thing you would find is any holes. So anything that is a common factor that's going to cancel out is a hole. So if you were finding a hole, that would be that one. The next thing you would find is anything that's left on the bottom after you simplify. So y is equal to 2 parentheses x plus 4 over x minus 3. So after you simplify, your problem can still have a 0 on the bottom. It's still a fraction, so you don't want any zeros on the bottom. A vertical asymptote is whatever makes this equal to 0. So if you're struggling with it, you can actually set it up and say, okay, x minus 3 is equal to 0 and solve. Add 3x can't be 3. So your vertical asymptote asymptote is equal to x equals 3. Now this is a vertical line, and it will be dotted at 3 on the x-axis. And we're going to do a whole bunch of examples. These are just examples to kind of get you used to it. If you are trying to figure out what is the difference between a hole and a vertical asymptote, they are very similar. They are both excluded values. So they are both excluded values. A hole is the excluded value that's going to get canceled off, and a vertical asymptote is the excluded value that stays in the problem. Alright, so next on our list is a little more complicated. So the horizontal asymptotes are actually an imaginary line. So the horizontal asymptotes are actually is an imaginary line, horizontal line, which is always in the form y equals a number, that the graph cannot cross. So horizontal asymptote is an imaginary line. Y equals a number that the graph cannot cross. Now, here's where the word degree comes back into play. And if you think about degree is very similar to the exponent, or it uses the exponent. So for these, we're actually going to be looking at the exponents. Most of these problems are going to be with just an x in there. So what you're looking at is basically the biggest degree of all of the problems. So biggest degree usually equates to the biggest exponent. And you're going to be making comparisons. So for example 1, if we have y equals 2x squared plus 3x minus 5 over 2x plus 7. So I would tell you go through all the same things first. You still need to do your holes, you need to do your vertical asymptotes, you still need to simplify, and all of that stuff. And if it doesn't simplify, you get to something like this. You might have to remultiply it or something like that. So you might have to remultiply or something. But basically what you're looking at is the degree. This one has a degree of 2. This one has a degree of 1, so it falls under example number 1. So the horizontal asymptote for this problem, there isn't one. So we would write none or not applicable or something like that to make sure that I know. Don't put 0 down, because if you guys notice on example number 2, if I write down f of x is equal to 3x minus 7 over 2x squared plus 4. So if you have an example that looks like that, 3x minus 7 over 2x squared plus 4, basically what ends up happening is the degree of the top, so that is a degree of 1, and the degree of the bottom, which is a 2, the bottom is bigger, so the horizontal asymptote for this example is y equals to 0. And then option number 3 is what happens if the degrees match. So if you have something like y is equal to 7x squared plus 9x minus 12 over 3x squared plus 8x minus 4. So if you have something like that, nothing simplifies. You notice that the degrees actually match. Degree was the largest exponent. The horizontal asymptote is actually just the leading coefficients of the numerator and denominator. Remember, coefficient is just the number, it doesn't include the x. So this would be y is equal to 7 over 3. So horizontal asymptotes, you actually have to make a choice, and it actually falls into one of 3 groups. Your groups include either the top one being bigger than the smaller one, the bottom being bigger than the top, or the degrees are equal. So you're making a choice on degrees now. After you simplify, you might have to distribute back out. You might have to do something like that to make sure that you actually know what the degrees are. But I would highly recommend simplifying first because it makes your life easier. So make your life easier. All right. And then last but not least on our list to do is a slant asymptote. A slant asymptote is just that. It is an imaginary line. It is a slanted imaginary line, and all slanted lines are in the form of plus b. It is a slanted imaginary line that your graph cannot cross. Alright. Now, the way this works is, you should still actually simplify. So you're still simplifying. Now, you are looking at degrees for this one. It is the degree of the top is exactly 1 bigger than the degree of the bottom. So, and here is the part that you're probably not going to like. You're going to have to use long division to actually do these. So let's make up one. Y is equal to 2x squared minus 3x plus 4 all over x minus, let's say, 7. Alright, so you tried to simplify it, didn't work, still looking at it. It has no horizontal asymptote because the degree of the top is 1 bigger than the bottom. So you move on to a slant asymptote. And in the case of a slant asymptote, you actually have to do long division. So I write down x minus 7 over here. And then 2x squared minus 3x plus 4. Underneath, remember all the rules with actually doing long division. You have to make sure that there's no jumps in your exponents. You have to make sure everything is in order, biggest exponent to smallest. Your denominator goes on the outside, numerator goes on the inside. So your job is to try to make this number, the first one, on the outside look like the inside. So you divide. And when you divide 2x squared by x, you're left with 2x. Then you have to distribute and multiply this. So this actually becomes 2x squared minus 14x. Draw the line. Subtract or change the signs. So that's gone. This is, it looks like to 11x plus 4. Make sure you bring down the next number. Next, 11x divided by x, or how do you turn x into an 11x? Well, it needs a plus 11. So 11 times x and 11 times negative 7 is negative 77. You draw this line, change these signs, you get 81 as your remainder. So now here's the nice thing. Your slant asymptote really doesn't worry about the remainder all that much. Your slant asymptote is only the equation without the remainder. So you don't actually have to write the remainder down. So it is y is equal to 2x plus 11. So you might have to do some long division. You might have to actually work through it. I would always tell you to do it after you simplify. So after you simplify, that's what I would look for. All right, let's do an example just to let everybody know how this works. So the first thing most of these problems will have you do is state any important information, and then we're sketching after that, and you're using your calculator to help you sketch it. So you are using your calculator to help you sketch this. So what ends up happening is, first thing you have to do to this one is actually factor. So factors of 6 that give you 1 would be 2 or 3, and it's going to be x minus 3, x plus 2, all over x plus 1. Alright, first one is any holes. Any holes exist wherever you canceled something out. In this problem, nothing cancels out, so there are none or no holes. Next would be a vertical asymptote. Vertical asymptotes are what makes the denominator equal 0. So in this case, what makes x plus 1 equal to 0 is actually -1, so the vertical asymptote is at x equals -1. While I'm here, I would go over to your graph and go ahead and put that vertical asymptote on x equals -1. Next, I would put down any horizontal asymptotes. So horizontal asymptotes go like this. This is multiplied out, so the one in red is actually multiplied out, so I'd go back to the original problem so I can look at the degree. The degree of the top is 1 bigger than the degree of bottom, so there is none on the horizontal asymptote. And in the case of the last one, which is a slant asymptote, we have to go over here and do some long division. So I have to do x plus 1 into x squared minus x minus 6. X into x squared is x. X squared plus x. Remember, you have to change those signs, though. It's a -2x minus 6. Minus 2, that's going to be a -2x minus 2. When I change those signs, it's a -4. I really don't care about the remainder. What I do care about is the x minus 2 on top. So your slant asymptote is y equals x minus 2. So slant asymptote goes down to 2, up 1, over 1. And your slant asymptote is this dotted line right in here. Alright, so that's just to get the kind of imaginary lines and everything on your graph. In order to actually graph this, you can do a couple things. We are actually going to do calculator sketches. So when you do a calculator sketch, I would highly recommend getting your calculator out and typing it in. Now there's a couple different ways you can type it in. I use the parentheses with a division bar. So I do parentheses x squared. I believe it was minus x minus 6 minus x minus 6. Close the parentheses because that goes on top. Divided by, too many minus signs. Divided by parentheses, and I believe it was x plus 1. When you hit graph on this, I'm going to kind of show you what it does. Now, what I would tell you is, in most cases, you look for important pieces of information that could help you out. So, for example, it looks like it crosses at the -1 on the x-axis. It also crosses at 1, 2, 3, 4, 5, 6 on the y-axis, and +3 on the x-axis. So you can actually use those dots to help you. So if we say it crosses at the -2, I would go over to -2 here. So put a dot, and then I would kind of just gingerly sketch this in. If it crossed at 1, 2, 3, 4, 5, 6, and then 1, 2, 3 here, I would do the same thing on that one. Sketches don't have to be perfect, but I am looking to make sure that they don't cross any slant asymptotes or any vertical asymptotes or any horizontal asymptotes. So that would be part of the grade. Alright, let's take a look at the next example. You will be doing the same thing over and over again. You're going to use that list. I would highly recommend that you have that list kind of at your disposal at all times. So what I would end up doing for this one is, first I would try to simplify. If you take a look, none of them actually simplify. So you start going through. So is there anything that you can cancel out? And in this case, nothing cancels. I can't make it any smaller. There's no x minus 3 on top and bottom. So the holes for this problem is none. Next, I would look at any vertical asymptotes for this problem. Vertical asymptotes are what makes the bottom equal 0. So x minus 3 equal to 0. X is equal to 3. So vertical asymptote is x equals 3. I would highly recommend that you go over to your graph paper, put in that x equals 3 line right there. Next, I would look for any horizontal asymptotes. Horizontal asymptotes look at this and they look for the degree. The degree of the top of this one is 1. The degree of the bottom is 1. If they match, the horizontal asymptote is the fraction 2 over 1 because it's whatever numbers are in front of those. So I go up to 2 on the y-axis and my horizontal asymptote is right there. And then last but not least, the slant asymptote. If the degrees match, there was no reason to do a slant asymptote. For a slant asymptote, you have to have a degree on the top, 1 bigger than the degree on the bottom. So a slant asymptote would be none here. Now, the way we're going to be doing this is we're going to be sketching using a calculator. So we'll go back to our graphing calculator. When you want to graph this, you want to graph 2x plus 9 over x minus 3. I would highly recommend going back to the original problems. So I would highly recommend going 2x plus 9, x minus 3. So I would do parentheses 2x plus 9 divided by x minus 3. Now you are welcome to use the shortcut for the fraction. So if you want to use the alpha F1 button and actually put it in as a fraction, you can do that. 2x plus 9 on top, x minus 3 on bottom. You are more than welcome to enter either one. When you hit graph, kind of watching the graph, how does it come on the paper from left to right? Watch the graph, how does it come on the paper? And these two should be the same. The red and the blue ones are going to be the same because one of them we just entered with the division bar, and the other one we just entered with the fraction key with parentheses and things like that. So they should be the exact same. Now let's talk about like how do I make sure I want the points where I got them. There are two ways you can do that. One, you can hit the trace button and you can kind of move your cursor and see what values are on these lines. It won't usually give you nice values. It will usually give you pretty nasty values, but it will get you close. -5 at 0.125 on the y-axis, things like that. And then the other one is you can actually go to the table and get these same values. So if you hit second and table, you can kind of see these values. So at -3, it should be -3. At 1, it's -5.5. At 2, it's -13. 3, there's an error. And that's because we have that vertical asymptote at 3. So it's one of those things where if we're being very picky about where does our lines cross and things, then I would tell you that you might want to make sure that you cross correctly. I am not that picky. I am more into getting kind of a general sketch just to make sure that I know you know how to use your calculator and work on it, and we should be okay. So if you ever come into the situation where somebody's actually asking you for where does it cross on the x-axis or where does it cross on the y-axis, then the idea is you can use the buttons on your calculator, such as the table button is your best bet, or the trace button on your calculator, to get those values exactly where you want them. If you do put those values, I would put dots on your graph so you can actually show the instructor where those dots belong and then draw your graph. Alright, let's do a couple more examples and then we should be done. So in the next example, it does require you to actually simplify first and actually kind of do the work for the holes and all of that stuff. So let's go through it. First, notice that doesn't really matter what the m of x, f of x, g of x, y equals is, but you are going to have to use that same terminology throughout. As you write it down, it is x, it's going to be x plus 3 parentheses x minus 2. And then on this one, it's going to be x plus 3 parentheses x plus 5. And we are doing some general factoring techniques. The multiply together to get 15, that add together to get 8, and then multiply together to get negative 6, that subtract together to get positive 1. So I will do this for you, just so that you guys recognize this. This is a common factor. So when you do wholes in this case, your wholes are whatever makes that equal to 0. And so when I say that, it's going to be negative 3 comma something. That something needs to be found by plugging negative 3 back into the problem after you simplify. So negative 3 take away 2, negative 3 plus 5. This is actually going to be negative 5 over 2. Now that magical hole on your graph is at negative 3 down 2.5, so it's about right there. And you actually have to put a hole on your graph. So there's a little dot, or a little, I shouldn't say dot because it's empty. Here's a little hole right there. Next, you have to find any vertical asymptotes. So after we simplify, there's still something on the bottom. The question is what makes x plus 5 equal to 0? And the answer is x is equal to negative 5. So the vertical asymptote is x equals negative 5. You go back to here, 1, 2, 3, 4, 5 to the left on the x-axis. I put a dotted line. Next, we would look for any horizontal asymptotes. So you have that list of stuff on your paper for horizontal asymptotes. And the way it works is I would always go to the one simplified. Here's a 1, here's a 1. The degrees match. So what you actually have to do is you have to go y is equal to whatever the numbers in front of the degrees are. So that is at y equals 1. And I dot that one in. Slant asymptotes, in order to be a slant asymptote, it has to be one bigger on top and one bigger on bottom. They are not. They are the same. So there is no slant asymptote. Now here's where it gets a little weird. You can actually do either one on your graphic calculator. I would tell you always go back to the original, because the original is actually going to show the whole, and the one where you simplified will not show the whole. So if I was actually graphing this on my graphing calculator, I would actually do the x squared plus x minus 6 on top divided by x squared plus 8x plus 15 on bottom. I would hit graph. Kind of watch it come in, see what happens. Notice you can't see the hole there because the pixels on the calculator are so small. But there is a hole at negative, I think it was negative 3 comma negative 2.5. So about right there is a hole. But it looks like it comes on the paper, leaves the paper. If you want to be exact, you can always go second table. Take a look at these numbers. 0, negative 4, it looks like 2, 0 is another one. So on and so forth. 9.5. You can actually get pretty accurate if you want to with your points on your graph. For our purposes, it's really not necessary for me. I just want you guys to kind of graph it. It comes on the paper, goes through there. Since the hole is on there, I would tell you to go ahead and go through that. Kind of go through that and leave the paper. When it comes to graphing, I think the sketch is actually the easier part. It's all the values that you have to find before that. So it's the holes, the vertical asymptote, the horizontal asymptote, and the slant asymptotes that are the more difficult to find. We'll go through one more example and we'll kind of show you kind of a hard one with a slant asymptote. But the way this goes down is same thing. I would tell you that you need to simplify. So this is x plus 2 on top, x plus 2 on top, 2x minus 1. There is no, I repeat, there is nothing that cancels out. So 2x minus 1 can't cancel out with anything there. So when it comes to a hole, or holes, there are none. When it comes to vertical asymptotes, it is whatever number makes the bottom equal 0 now. So this one is a little more difficult. You might want to actually write this one down when you solve it. You have to add 1 and then divide by 2. So it's actually x equals 1/2. So your vertical asymptote is actually at x equals 1/2. Also a little difficult to graph because normally your graph paper does not have halves on it. So the vertical asymptote is at 1/2. Horizontal asymptote, the degree of the top is bigger than the degree on the bottom, so there is none for that. And then the slant asymptote is, I think, the hardest slant asymptote that we have on the examples, because this one you actually have to do 2x minus 1 and then x squared plus 4x plus 4. You actually have to do, how do you turn a 2x into a kind of a 1, and it's actually 1/2 x. So this becomes an x squared minus 1/2 x. Don't forget to change the signs. That one cancels. This becomes plus 4.5 x plus 4. And the next one here is, how do you turn a 2x into a 4.5? And I think it is plus 2.25. 2 times 2 is 4, 2 times 1/4 is 1/2, so that should be right. 4.5 x minus 2.25. Don't forget to draw the line. Change them. So we change them, it becomes, let's see, 6.25. Don't even care about the remainder though, I really only care about this piece. So the slant asymptote is y equal 1/2x plus 2.25. And I changed that to a decimal to make it easier for me to graph on my graph paper. It crosses at about 2 and a little bit more. And it goes up 1/2, up 1/2, up 1/2. So the slant asymptote is probably in there somewhere. Alright, now I go back. Y equals, anytime you want to clear something out, just clear it out. It is parentheses x squared plus 4x plus 4. And we're dividing that by 2x minus 1. And our hope is that when we graph this, looks like it comes on that slanted line and then shoots down and then leaves on the slanted line. So always kind of pay attention how it comes on and leaves the paper to help you graph it. So to me it looks like it comes on and then kind of left quickly, and then when it comes back on and leaves that way. So when it comes to graphing rational expressions, this is kind of what it's expected of you. Holes, vertical asymptotes, horizontal asymptotes, slant asymptotes. And then you're also supposed to use your graphing calculator to help put all those lines and put the whole graph together.